Hey guys, Mr. Milton here. Today we're going to look at lines in the coordinate plane. At the end of this notes, you should be able to write equations and lines from a variety of information, and you should be able to graph lines. Okay, this is almost, you can think of this as an algebra review of how to write lines on the coordinate plane, since all this stuff should be a refresher from then. So there are three main forms of linear equations. And they are slope-intercept form, which is y equals mx plus b. This is our most common form here. Point-slope form, which is y minus y1 equals m times x minus x1. And then standard form, which is ax plus by equals c. Okay, so we should be very familiar with slope-intercept form. M stands for slope. B is our y-intercept. Okay, in point-slope form, it's called point-slope form because we need the point and a slope to use it. Okay, for point-slope form, x1, y1 are from the point that we know or we're trying to find out. And M is our slope again. Okay, x and y are kind of just there. And then for standard form, this is typically found or used to find intercepts. Okay, so we can use this to find x and y intercepts. So that's intercepts. Its purpose. So let's look at some problems here. Here it says transform each of the following into slope-intercept form. So they're asking us to do into slope-intercept form. The main characteristic of slope-intercept form is that y is by itself. Okay, and so basically they're asking us to solve for y here. So for this problem, getting y by itself, I'd subtract 5x from both sides. That leaves me with 2y equals negative 5x plus 18. Get y all the way by itself by dividing by 2 on both sides. And so then I'll get y equals negative 5 halves x. 18 divided by 2 is 9. And so here is my answer. Y equals negative 5 halves x plus 9. Okay, remember that we want to use fractions rather than decimals because this fraction is the slope. It tells us go down 5 and to the right 2. And 2.5 doesn't necessarily give us as much information. All right, number 2. Again, put it in slope-intercept form means solving for y. So I'm going to subtract x from both sides. That gives me negative 3y equals negative x minus 15. I'll divide both sides by negative 3. So then y equals negative divided by negative is positive. 1/3 x plus 5. So there we have it. Put it in slope-intercept form. That's very useful because slope-intercept form is one of the better forms to use when graphing. All right, our next problem says write the equation of the line in slope-intercept form that goes through the 2 points. Okay, there are 2 different methods that you can use, and so I'll show you both. You can choose whichever one you like. So first one, I'm going to use basically using y equals mx plus b. Okay, so here's how you do it. Again, m stands for slope. We have to find the slope. In both of these situations, actually, we have to find the slope. And so our slope formula, if you remember, is y2 minus y1 over x2 minus x1. Okay, and so we can plug those values in, x1, y1, x2, y2, and solve. So y2 is 10 minus y1, 7 over x2, 2 minus x1, 3. So 10 minus 7 is 3. 2 minus 3 is negative 1. Our slope is negative 3. Okay, this first time I'm using y equals mx plus b. And so what I'll do from here is I will take my value, m, and one of these points and plug it into this formula and then solve for b. Okay, so I'm going to use this point of 3, 7. Doesn't matter which one you use, but that's the one I'm going to use. And so in y equals mx plus b, I'm going to plug in my y, which is 7, my m, which we found to be -3, and my x, which is 3. And I'm solving for b. So 7 equals -9 plus b. Add 9 to both sides, and we find out that our b is 16. So for slope-intercept form, I need the slope and the intercept. I just solved for the intercept. We used the slope formula to find our slope. And so my final answer should be y equals, my slope is -3, x plus 16. Okay. Second way that we can run through this is using point slope. Okay. So point slope form, again, you'll need the slope. And so I'll do that first. Label my points just so I can make sure I'm all organized, not making small, avoidable mistakes. So y2, 9, minus y1, 6, over x2, 2, minus x1, 4, or -4, so plus 4. So 9 minus 6 is 3. 2 plus 4 is 6. My slope is 1/2. Okay, now I'll use that one of the points. And the point that I'm going to use is 2, 9. I could choose either of the points. But in this case, I'm choosing 2, 9 because they're both positive, and so I have less to worry about with forgetting a sign or messing it up. And so in point slope form, again, that's y minus y1 equals m times the quantity x minus x1. I'm plugging in the information I know. Y minus, and my y1 is, where is that at? Oh, that's 9 because I used my y2, okay. Equals my slope 1/2 x minus 2. Okay, so on this right side, I'm going to distribute. Y minus 9 equals 1/2 x minus 1. And to get y all the way by itself, I'm going to add 9 to both sides. And I get y equals 1/2 x plus 8. Okay, so either method that you like there to solve works out. Reminder that all horizontal lines have a slope of 0. And if we are writing their equation, it always starts with y equals, right? So on the number line for our lines here, an example of this might be like, oops, I tried to make it horizontal. Let's pretend that it is. An example of this could be y equals 2. And anywhere on this line, the y coordinate would be 2. Okay, vertical lines have an undefined slope, and it starts with x equals. Again, vertical, think about a vertical jump here. Okay, starts with x equals. So somewhere on here, an example, maybe this would be like x equals -5. Okay, because here, all along this line, any x coordinate would be -5. Okay, that's one way that you can help yourself out. You just say, okay, what are the x coordinates on this line? What are the y coordinates on this line? And then you'll see whichever stays consistent. Along those lines, it says to write the equation of the horizontal and vertical lines that go through each point, -7, 2. And so if we see that the point -7, 2, -7, 2 would be right here. The horizontal line here, remember what I said, that on a horizontal line, our y coordinate stays consistent. And so what's our y coordinate at this point? Well, our y coordinate at this point would be 2. So the horizontal lines equation, y equals 2. Just like my example. Now I wish I used a different number. All right. For our vertical line, okay, it would be vertical through this point. And like we said, for a vertical line, the x coordinates stay consistent. Okay, what's our x coordinate here? -7. So x equals -7. Those would be the lines that go through that point. Okay, on the next page, they're just asking us to graph these different lines. And so let's do that. A few of these are given to us in slope-intercept form. Remember, slope-intercept form, we would start with the intercept. That's where we start. So our intercept is 2. It's always on the vertical line here at 2, where we start. Our slope is 1/3. Remember, the slope is rise over run. And so it tells us go up 1 because it's positive. Positive means up. And to the right 3 again because that's positive. Positive means right for our horizontal. So continue to do that. Up 1/3, down 1, left 3, down 1, left 3. Okay, and here's our line, solid line that goes through here. I'll try as best as I can to be straight, but no promises there. All right, I could have done worse. Okay, our second line is also in slope-intercept form. Notice here that our slope is not as a fraction right now. I always help myself out and make sure I put a whole numbers over 1 so I don't just keep going down 2. I go down 2 over 1. So I start with my y-intercept, which is positive 5. 1, 2, 3, 4, 5. And then I go down 2 to the right 1. Down 2 to the right 1. I can continue that pattern. Okay, and that should give me my line. Okay, remember that negative slopes fall to the right, positive slopes rise to the right. Okay. Okay, if you do 2 negatives, if you went down and to the left, it would make a positive slope. So if there's negative, make sure you don't do negative over negative. Only one of those directions should be negative at a time. Otherwise, you're making a positive slope. All right. Here's our graph. Number 3 is also in slope-intercept form, and that's because y is by itself. You'll notice that it doesn't have a plus anything or a minus anything, but that is because it's plus 0. We don't have the right plus 0, right? And so our y-intercept is 0, or at the origin, and our slope tells us to go up 3, 1, 2, 3, and over 4, 1, 2, 3, 4. We could go down 3, 1, 2, 3, and to the left, 1, 2, 3, 4. Okay, you should notice that this is a line. Okay, and all of these are lines. If you get a Thunderbolt or a Pac-Man or something like that, then that is a sign that you messed up. You need to go back and check that out. All of these should just be lines.
Number 4, we kind of talked about this already. X equals by itself, that is a vertical line. So I'm going to help myself out and find out where x equals 4. 1, 2, 3, 4. X equals 4 here. Okay, x equals 4 here. X equals 4 here. X equals 4 all up and down this vertical line. So to make my line. All right, so there you go. That's the x equals. These last couple are not in slope-intercept form, but that is okay because we can graph. If either we can graph this in these forms, or we can convert to slope-intercept form, and that's what I would recommend that you do, is just convert to slope-intercept form. Okay, and that just means solving for y. So as we did earlier in this notes, subtract 3x from both sides. I have 2y equals negative 3x plus 4, and then divide by 2. And so then I get y equals negative 3 over 2 x plus 2. And then I can graph. Y-intercept's 2. Slope tells me to go down 3, 1, 2, 3, and over 2. Go down 3, 1, 2, 3, and over 2. Down 3 over 2. I could also go up 3 and to the left 2. Up, no, there's not enough space, but there you go. Okay, I'll try to keep this straight line. And finally, we have y plus 5 equals negative 2/3 x minus 3. A couple ways you can do this. One way you can do it is you can basically decipher point slope form and say, okay, if it's y minus y1 m x minus x1, you could take out and say, okay, what's my x1 value? Minus 3, so that means the x must be positive. What's my y1 value? Plus 5, that means the y must be negative. What's my slope? Negative 2/3. And basically you start at 3, -5, and then follow this slope. That's one way you could do it. The other way that you could do it, and really the way that I would recommend because it's not different, and therefore doesn't feel like something new to remember, is I just solve for y. Okay, and so on this side, I'll distribute -2/3 to both terms. So I have y plus 5 on my left because I haven't changed that at all. And on the other side, I have -2/3 x, so distributing. And then negative times negative is positive, 6/3, or 2, +2. And then solve for y, get y all in by itself by subtracting 5 from both sides. So we get y equals -2/3 x minus 3. So down 1, 2, 3. And then my slope tells me to go down 2 to the right, 1, 2, 3. Down 2 to the right, 3. Or up 2 to the left, 3. Up 2 to the left, 3. Okay, solid line. Again, if we took this and we were like, okay, let's do this. We're starting at the point 3, -5. 1, 2, 3, -1, 2, 3, 4, 5. And then following the slope, -2/3, so down 2/3, up 2/3. We would be at the same point. So either way works out. All right, so that's review for really algebra, graphing lines,